Now we're going to look at this from a different perspective here. We're given four graphs. They look like they're graphs of polynomial functions labeled a, b, c, and d. And we're told that they are the graphs of a function f and some derivatives, f prime, f double prime, and f triple prime. We're to identify which is which and explain our choices. I'd like to turn your attention to the graph of d, the orange one. It has a couple of places where the tangent line is horizontal. And it starts out with a positive slope. I should say over here, the slopes of tangent lines are positive. And then there's this middle portion where the slopes of the tangent lines would be negative. And then we're back here to where slopes of tangent lines would be positive again. Notice the green function here, where d has horizontal tangents, the green function is equal to 0, has an x-intercept. That happens at both times. Also, in the interval where the slopes of the tangent lines of d are negative, the graph, the green graph of c, is also negative. For those reasons, I'm going to say that c is d prime. If this, where the tangent is horizontal, means I'm looking at x-intercepts for one of the graphs, is a little bit challenging. Let's go back to the previous exercise here. And notice when we had a place where the tangent line of f was horizontal, we associated that with a 0 slope or an x-intercept for the graph of f prime, right? So I'm just using that thinking here. So we can say that we're looking at horizontal tangents for d and x-intercepts for c. And we also used positive and negative slope values and function values, but I don't want to write all that. All right, let me clear this away here. And now let's look at the graph of c. We have here a place where the tangent line is horizontal. So I'm looking for another function that has an x-intercept at the origin. Well, they all have an x-intercept at the origin. But notice to the left of the y-axis, the slopes of the tangent lines for the green one, for c, are negative. And to the right of the y-axis, the slopes of the tangent lines for c are positive. And notice that b is such that to the left of the origin, its function values are negative, and to the right of the origin, its function values are positive. Therefore, I'm going to say that b is c prime. And here I'll make that statement about, so positive and negative function values for b correspond to positive and negative slopes for c. Now, this is kind of a mind job here. If b is c prime and c is d prime, then we can say that b is d double prime. I know it's kind of out there. Just stare at it for a minute, it'll make sense. Now let's turn our attention to b. I have to the left of the origin positive slopes. They're negative function values because they're below the x-axis, but the slopes of tangent lines are positive. And that's kind of what this is about, is differentiating. I don't mean differentiating as in derivatives. Sorry, distinguishing between function values and slope values, right? So to the left of the origin, I have positive slopes. To the right of the origin, I have positive slopes. And at the origin, it goes horizontal. So I'm looking for a graph that is always positive or 0. And that's going to be A. So A is b prime. The function values for A correspond to the slope values for B. So A is positive or 0, and the slopes for B are positive or 0. Now for that mind job again. If A is b prime and B is c prime, then A is c double prime. We're going to keep going. if B is D double prime and A is B prime, then that means that A is D triple prime. So D is F. C is D prime, so C is F prime. B is F double prime. A is F triple prime. Again, if you need to stare at all that, there you go.